Jai Jagannath. So, in the last class, we had discussed the concept of charge. So, today we will start same chapter number 21 of University Physics. So, we will discuss now Coulomb's law. Coulomb's law. So, what is Coulomb's law? So, you see, Coulomb's law is applicable for point charge body. Coulomb's law, it is applicable for point charge body. Now question comes, what do you mean by point charge body? So if a charge body has no dimension, that means no shape, no volume, so that type of body is called point charge body. Or we can say, suppose you take two body, but they are far away from each other. If the distance is very large, tends to infinite, these two bodies are treated as point body. So for this point charge body, we can apply the Coulomb's law. Okay, so now every law has two law, that is qualitative law, another is called quantitative law. So qualitative law means, so we can say Coulomb's first law. Coulomb's first law. So Coulomb's first law gives the qualitative definition of first law. So what is Coulomb's first law? Equal charges repel each other, and or you can not equal charges, similar charges. What do you mean by equal and similar? I will explain. Similar charges repel and dissimilar charges attract each other. So what do you mean by similar charge? That means charge having same sign. Okay, suppose I will take, this is Q1, this is Q2, they are separated by what distance? R distance. If the product of Q1 and Q2 greater than 0, we can say these are similar charges, or you can say like charges, like or similar charges. Because you see, if this is positive, positive into positive is always positive, so which is greater than 0. If I'll take Q1 negative, Q2 is also negative into negative is also positive, which is greater than 0. So this is the condition for similar charges. Now for dissimilar charge, what will happen? The product is less than 0. This is for unlike charges, unlike or dissimilar charges. So if Q1 is positive, Q2 is negative, the product is negative, which is less than 0. So according to the first law, similar charge repel each other, dissimilar charge attract each other. Suppose I will take Q1 is positive, Q2 is also positive. Now this Q1 will repel Q2 by the force called F12, and Q2 repels Q1 by a force is called F21. So what is F12? F12 is force by Q1 on Q2. Similarly, what is F21? F21 is force by Q2 on Q1. So they are opposite to each other. Similarly, if I will take, this is negative, this is also negative, again each charge repel to other. But if I will take Q1 is positive, Q2 is negative, then this positive charge will attract negative charge by a force F12, and this negative charge will attract Q1 by a force that is F21. Okay, so this is the first law. Now every law has two definitions. One is qualitative definition, another is quantitative definition. This is called second law. Second law, Coulomb's second law is called quantitative. Second law gives the quantitative measurement, quantitative definition of Coulomb's law. So, according to the Coulomb's law, what will happen? Either there is a force of attraction in case of dissimilar charge, or force of repulsion in case of similar charge. So, according to the second law, the force of attraction or force of repulsion is directly proportional to the product of two charges. If the magnitude of charge are more, force between them is also more. And also, it depends upon the distance between two charges. If distance increases, force decreases. If distance decreases, force increases. So we can say force is inversely proportional to square of the distance. Or we can say F is proportional to Q1 Q2 by R square, or F is equal to some constant into Q1 Q2 by R square. So this constant K is a proportionality constant which depends upon. So K depends on what? K depends on nature of medium. Nature of medium. On which medium both charges are placed. Depending upon nature of medium, K value changes. Also, K depends on system of unit of measurement. On which system of unit you are measuring the force, K depends. So we are mainly taking in which system? SI system. In SI system, the value of K is taken to be 1 upon 4 pi epsilon naught epsilon r. So this is the constant. So we can write F is equal to, in place of K, I will write 1 by 4 pi epsilon naught epsilon r. So F is equal to Q1 Q2 by 4 pi epsilon naught epsilon r square. So from this I can say epsilon naught is equal to Q1 Q2 by 4 pi epsilon r into r square. So what is epsilon naught? Epsilon naught is called absolute permittivity of which medium? Air medium. We generally take air medium as the reference. So in that air medium, what is the permittivity? So that is called epsilon naught, whose value is equal to 8.854 10 to the power minus 12. So you have to remember this. And if you calculate, if you find the unit of epsilon naught, you see epsilon naught is Q1 Q2 by this. So Q1 Q2 Coulomb. So Coulomb square divided by 4 pi, it has no unit. Force unit is Newton. Epsilon r is the relative permittivity. Any relative quantity has no unit. So epsilon r has no unit. And this is distance square, that is meter square. So this is the value of epsilon naught. Then what is epsilon r? Epsilon r is called relative permittivity. Relative permittivity of that medium, which is unitless. Any relative term has no unit. So take a screenshot, write down the note. So I can write epsilon naught is the absolute permittivity, which is equal to 8.854 10 to the power minus 12 Coulomb square Newton inverse meter minus 2. So now if I'll write what is the force between two charges, we can write Q1 Q2 by 4 pi into epsilon naught, which is equal to 8.854 10 to the power minus 12 into epsilon r into r square. So this 4 pi, this 8.854 10 to the power minus 12, all are constant. So if you calculate 1 by 4 pi into this, you will get approximately 9 into 10 to the power 9. This is your Q1 Q2 divided by epsilon r. So I am writing epsilon r here and r square. So this is the force between any 2-point charge body. So you have to remember, basing upon this, you will get so many problems in the exam like that. So now you see the value of this epsilon r is equal to 1 for AR medium. For AR medium. So I can write so what is epsilon? What is epsilon? Epsilon is taken to be epsilon naught into epsilon r. So epsilon is called permittivity of a medium, and epsilon naught is called absolute permittivity, that is permittivity of which medium? Air or vacuum. And epsilon r is relative permittivity. Suppose you see, let us take the relative permittivity of glass is equal to 81. That is relative permittivity of glass is say 81. Then what is the permittivity of glass? It is 81 times the permittivity of air. So that is the concept of relative permittivity and absolute permittivity. Now you see the force. You see, suppose this is Q1, this is Q2. Let us say both are similar charge, positive. So Q1 will repel Q2 by a force F12. Q2 will repel by a force which is equal to F21. So you see both F12 and F21 magnitude is what? 9 into 10 to power 9 divided by epsilon r, Q1 Q2 by r square. Magnitude are same, but you see the difference, direction. So direction both are opposite. So I can write F12 vector is equal to minus F21 vector. So we know, according to Newton's third law, every action has equal opposite reaction, and action and reaction never act on the same body, and their magnitude is equal, direction is opposite. Now you see here F12 is the force on Q2 by Q1. F21 is the force by Q2 on Q1. Both magnitude are same. They are acting on two different particles, and their magnitude are same. Their direction are opposite. So we can say Coulomb's force is treated as action and reaction pair. Action and reaction pair. Clear? So now this formula is the scalar value, that is force. We can get the magnitude. But we know force is a vector quantity. So if it is a vector quantity, so we will write the force in vector form. So force, if we will write an arrow mark, that will give in vector form. So magnitude will remain same, that is 9 into 10 to the power 9 by epsilon r, Q1 Q2 by r square, and we have to take a unit vector. That unit vector is r cap. So this r cap is what? Is unit vector. And what is the direction of this unit vector? The direction of unit vector is same as direction of force. Direction of force vector. So we will say along the force direction, this is the unit vector. So when we will solve some problem, I will detail explain how we will find the unit vector. Okay. So now we see. Suppose, force in air medium, if we calculate the ratio of force in air medium to the force in any other medium, we will always greater than, so what is the value? Force in air medium. So I am writing here. Force in air medium is what? 9 into 10 to the power 9 Q1 Q2 by epsilon r is equal to 1 for air. So this is the force in air medium, divided by force in any medium is equal to 9 into 10 to the power 9 into Q1 Q2 divided by epsilon r into r square. So if we take the ratio, epsilon r will go to this. And we know epsilon r minimum value is 1. And for any other medium, epsilon r is greater than 1 for any medium other than air. So conclusion is that if epsilon r is greater than 1, then force in air medium between two charged particles is greater than force in any other medium. So this is the okay. So now we will compare. So what is the Coulomb's force? You see, Coulomb's force is treated as action and reaction pair. So this is very, very important. Coulomb's force is treated as action and reaction pair. And we can say Coulomb's force is a central force. Coulomb's force is called central force. So what do you mean by central force? Central force means the Coulomb's force always acts along the line joining between the center of two charged bodies. So Coulomb's force always acts along the line joining the center of two charged bodies. That's why it is called central force. Coulomb's force is called central force. Now, what is gravitational force? You know, in the 11th class you have read, suppose there are two bodies, one is m1, m2, distance of separation is r. So here m1 will attract m2, m2 will attract m1. That force is called gravitational force of attraction, which is equal to some constant, that is g m1 m2 by r square. This is the gravitational force of attraction between two bodies. And this is the electrostatic force of attraction or repulsion between two charged bodies. So we will compare the gravitational force and electrostatic force. So what is the similarity? So we'll see what is the similarity between gravitational force and electrostatic force. So similarity between electrostatic force and gravitational force. So what is the similarity? Similarity is that both obeys inverse square law. Inverse square law. That is, the force between two charged body or force between two mass is inversely proportional to square of the distance. So this is the similarity. Second similarity is that both are central force. Both are called central force. That means the force lies along the line joining between the two center, between the center of the two bodies. And both are conservative force. Both are conservative force. Electrostatic force and gravitational force, both are conservative force. What do you mean by conservative force? We have read in the mechanics chapter. Conservative force is that force by which or against which, when work is done, that work is independent of path followed. It depends upon only initial position and final position. So that's why here both forces are the conservative force. Next, what is dissimilarity? What is dissimilarities between electrostatic force and gravitational force? So what is the dissimilarity? You see, electrostatic force is either attractive or repulsive depending upon nature of charge. But gravitational force is always attractive. So this is the dissimilarity between gravitational force and electrostatic force. And what is the value of gravitational constant? G is equal to 6.67 10 to the power minus 11. What is the unit? Newton meter square kg minus 2. So this gravitational constant does not depend on does not depend on nature of medium. It is always constant. That's why it is called universal constant. Everywhere this G value remains constant. And generally this value is very small. G value is very small. But if we'll take the K value, that is electrostatic force constant, that is K. So what is K actually? So we know F is equal to K Q1 Q2 by R square. So what is the value of K? K is equal to 9 into 10 to the power 9 divided by epsilon R Q1 Q2 by R square. So this K value depends on nature of medium. And practically its value is very large. You see 9 into 10 to the power 9 here. Here 6.67 into 10 to the power minus 11. So that's why K depends upon nature of medium and its value is large. So now let us take an exercise problem. Solution. Now see, suppose there are one electron, another proton. The distance of separation between electron and proton is r. So there is a force of attraction, electrostatic force of attraction, because electron is a negative charge, proton is a positive charge. So there is a force of attraction. So that force is equal to say Fe. And since electron has a mass, proton has a mass, so there is also a gravitational force of attraction. So that gravitational force of attraction is say Fg. So now we will compare what is the ratio of electrostatic force to gravitational force. Now what is the formula of electrostatic force of attraction? 9 into 10 to the power 9 divided by epsilon r. Let us say we are taking in air medium. So for air medium, epsilon r is equal to 1 into Q1 into Q2. So Q1 means charge of electron. What is the value? 1.6 10 to the power minus 19 Coulomb. And what is the charge of proton? Same. So square divided by r square. Then what is the gravitational force of attraction between electron and proton? We know G m1 m2 by r square. So what is the value of G? 6.67 10 to the power minus 11 into mass of electron. I think mass of electron is 9.1 into 10 to the power minus 31 kg into mass of proton. What is the mass of proton? 1.67 10 to the power minus 27 kg divided by G m1 m2 by r square. R square cancel. So if you will calculate through calculator, you will get the 2.27 into 10 to the power 39. You see, the order of the force is coming to be 39. That means the electrostatic force is very, very greater than the gravitational force between electron and proton. Now we will see limitation of Coulomb's law. What are the various limitations of Coulomb's law? Every law has some merit and demerit. So what is the limitation of Coulomb's law? First, it is, I had told, Coulomb's law is applicable for point charge body. That means it does not applied. This law is not applied. This law is not applied for extended charged body. Extended charged body. We cannot apply this Coulomb's law to a big charged body. Second limitation. Second limitation is that if two charged bodies are in motion, we can't apply which law? Coulomb's law. So Coulomb's law is not applied to two charged body when they are in motion. Only applicable when both are at rest, or one is at rest, another is in motion. So these are the limitation of Coulomb's law. So now we can see what is superposition principle. Superposition principle. What do you mean by superposition principle? Suppose you see there are four charges, Q1, Q2, Q3, Q4. I want to find force on Q4 charge by the remaining three charges. So what we will do? First we will find what is the force on Q4 by Q1 charge. So let us say that is F14. Then we will find what is the force by Q2 on Q4. Let us say this is F24. Then you find force on Q4 by Q3. Let us say this is F34. And since force are vector quantity, we will add all these force vectorially. So this is the total force on any charge due to presence of other charges. So how will you find? First find out the force, individual force acting on this body. Then take the summation. So that will give the total force, which is called superposition principle. Now see, in the presence of other charges, the force between two charged body will not change. You see, suppose there is no Q2, no Q3, only Q1 and Q4 are there. So when you will calculate the force between these two bodies, the same formula, same magnitude you will get if other charges are also present. But net force on any charged body depends upon the presence of other charged body. I think it is clear. So this is called superposition principle. Solution. You see, take an example 21.4 of this book. Two equal positive charges Q1, Q2 of 2 microcoulomb are located at x is equal to 0, y is equal to 0.3, and x is equal to 0, y is equal to minus 0.3 meter. So let us draw. Suppose this is your y-axis, this is your x-axis. So two charges are there. One is Q1. Q1 is 2 microcoulomb. So here the coordinate is 0, y coordinate is 0.3. Another charge is Q2, that is also 2 microcoulomb, and here the coordinate is 0, minus 0.3 meter. And you take another charge particle whose magnitude is Q, whose value is 4 microcoulomb. Its position is x coordinate is 0.4, y coordinate is 0. Now question is, you have to find the electric force by Q1 and Q2 on this Q charge. So how will you find? Now see, you see, this is positive, this is positive. So first we'll find what is the force by Q1 on Q charge. So you see, this distance is equal to 0.3. This to this point, distance is 0.4. Now you calculate what is this distance. What is this distance? So definitely this distance is equal to 0.3 square, 0.4 square root, which is equal to 0.5. Similarly, the distance between this to this is also 0.5 meter. So first we find what is the force by Q1 on Q. So what is the formula? Formula is 9 into 10 to the power 9. Q1. What is Q1? 2 microcoulomb. 2 micro means 10 to the power minus 6 into Q. Q is 4 microcoulomb. 4 into 10 to the power minus 6 divided by square of the distance. What is the distance here? 0.5. So 0.5 per square. So if you calculate, it will give 0.29 Newton. Similarly, we can find the force by Q2 charge on Q is equal to, I can say it is F2 on Q. Is same. Magnitude of charge are both same. Distance is same, 0.5. So you will get same result, that is 0.29 Newton. And what is the direction? You see, this is positive. This is positive. So this positive charge will repel this positive charge along this direction. So this is your F1 on Q. Similarly, this is positive. This positive will repel this positive by same force. So here it is, that is F2 on Q. So just extend this. Let us say this angle is theta. This angle is also theta. And this is also theta. This is also theta. So now how will add these two vector? You know there are various law, triangle law of vector addition, parallelogram law of vector addition. But it is better to take the addition by which method? Using component method. So first, so we will find what is the total force on Q charge. Total force on Q charge is nothing but force by 1 on Q plus force by Q2 on Q. You just add vectorially. How will add this vectorially? So by using component method. First you calculate the what is the x component of this force. So this is your F1. This is theta. So what is the x component of this force? It is F1. What is the value of F1 on Q? This is 0.29. 0.29 cos theta. So that is equal to 0.29 cos theta. If this is theta, this is theta. Cos theta is base by hypotenuse. What is base here? Base is 0.4. What is hypotenuse? 0.5. So 0.4 by 0.5. So if you calculate, it will give 0.23. And what is the direction of this x component? Direction of this x component is towards right. So I am writing here I cap, and unit is nothing but Newton. Similarly, you find what is the so this is your F2 on Q. So now you find out what is the S component of this F2 force. So F2 S component F2 force is also this into cos theta. So this value is 0.29. Cos theta is also 0.4 by 5. So you will get same result, that is 0.23 I cap. Then you find out what is the y component of F1. So F1 y component is equal to, what is the value here? Force value 0.29 into sine theta. And this y component will lie along negative direction. So I can say it is 0.29 sine theta. So what is sine theta? P by h, that is 0.3 by 0.5. 0.3 by 0.5. So if you calculate, you will get 0.174 Newton. But it is lying in which direction? Negative y direction. Here you write down minus j cap. Similarly, find out y component of this F2 force. Y component of this force is equal to what? 0.29 sin theta, which is equal to 0.174. But here y component will lie in positive y direction. That's why I am writing J Newton. So if we'll calculate all the x component, what is all the x component? Fx is equal to, you see, the both x component are lying in same direction. What is the magnitude? 0.23i, 0.23i. So if we'll add, you will get 0.46i cap. And what is the total y component? So one y component is upward, another is downward. Both have magnitude same, direction is opposite. So net y component is 0. Then what is the total f? Total f is equal to total x component plus total y component. What is total x component? 0.46 i cap plus 0 j cap. So this is the force value. And if we calculate the magnitude, so magnitude is equal to what? S component square, y component square, square root. So we can say it is 0.46 Newton. And along which direction? Along positive x direction. That means due to these two charges will exert force on this Q along which direction? Positive x direction. So net force is equal to 0.46 Newton along positive x direction. So this is the solution of this numerical. Now immediately we will solve a test or understanding 21.3. Test or understanding 21.3. Just in the last example, in example 21.4. In 21.4 example, if Q2 charge, initially Q2 charge were what? 2 microcoulomb. Now if I will take Q2, if Q2 were minus 2 microcoulomb, if the value of charge Q2 is changed from 2 microcoulomb to minus 2 microcoulomb, solution, you see, you take a test year understanding 21.3. In the last example 21.4, so here Q1 is equal to 2 microcoulomb and here we had taken Q2 is equal to 2 microcoulomb. We were calculating the force on 4 microcoulomb. But in this example, if Q2 were minus 2 microcoulomb, now this Q2 which was initially 2 microcoulomb, now if we will keep Q2 is equal to minus 2 microcoulomb, then what will be the total force on Q? Various options are given. So here we will not calculate the magnitude of the force on Q, only we will find what is the direction of the force. Okay, now you see. So here Q2 is equal to not 2 microcoulomb, Q2 is equal to minus 2 microcoulomb. What will happen? This Q1 is positive, this Q is positive. So this Q1 charge will repel this Q along this direction. This is say F1. And this Q2 is a negative charge, this is positive charge. This negative charge will attract this positive charge towards it. So this is say F2. And both magnitude F1 is 0.29 Newton. Here F2 is also 0.29 Newton. Now if we calculate what is the total force on this Q charge, then what will be the direction of the force? So it is very simple. Now see, in this case, what we will do? Let us say this is theta. This angle is also theta. Now if we will add these two force, we will take which method? Component method. So the x component of F1 will lie along this direction, and x component of F2 will lie along this direction, and this F1x magnitude is also equal to F2x magnitude. So the total x component will be what? 0. They will be cancelled. Only which component will lie? That will be present. That is y component. What is the y component of F1? Here it is 0.29 sin theta. That will lie along this direction. And the y component of this F2 will also lie along this direction. So that means the y component, the total y component will be F1y plus F2y. Both are in which direction? Negative y direction. So the total force will be along which direction? Negative y direction. So which answer is correct? So this is the correct answer. I think it is clear. So this is one test your understanding 21.2. So this question is a very fundamental question. You see, one sphere has a negative charge. So we will solve first bit. One sphere has a negative charge and other is uncharged. Other is uncharged. So let us say this is A, another uncharged sphere B. When they are close to each other, when they are very close to each other, this is charged body, this is uncharged body. Then when they are close to each other, force between them is attractive or repulsive or no force. So what is your answer? Just pause this video and think over this. Okay, I am doing. So this is negative charge, this is uncharged body. So when they are very close to each other, what will happen? So here, what will happen? This side will behave positive, this side will behave negative charge. According to which principle? The principle of induction. Okay. So now you see, this negative charge will attract this positive charge. By which force? Let us say F1. F1 is which force? Attractive force. F1 is which force? Attractive force. So now this negative will repel this negative by which force? F2 force. Let us say this is which force? Repulsive force. Now out of F1 and F2, which is greater? You see, F1 is force between negative and positive. So these two charges is nearer to each other. R is less. So force is inversely proportional to R square. So here force will be more. So F1 is more than F2 because for F2 this negative and this negative is away from it. So if R increases, force decreases. So repulsive force is less than that of attractive force. So what is the net force between these two bodies? One is attracting, another is repulsing. Attractive force is more than repulsive force. So net force will be definitely attractive. Suppose F1 is attractive force is 5 Newton. Repulsive force is less, 3 Newton. So what is the net force? 5 minus 3, that is 2 Newton. 2 Newton is which force? Attractive force. So first bit answer is attractive. Come to second bit. Second bit. When both are contact with each other, that means this is A body, that is negative charge. This is uncharged body, B. This is uncharged body. When they are in direct contact, what will happen? You know, according to the conduction principle, if the two bodies have same shape, same volume, same material, the charge will be divided. Let us say total charge was minus q. So after they are made contact, so here charge will be minus q by 2 for A, and here the charge will be minus q by 2. So this is A, this is B. So this is negative, this is negative. So what will be the force between them? So since they are negative, negative, similar charge, they will repel. So A will repel to B, B will repel to A. So the force is repulsive. So today in today's class, I only discussed the Coulomb's law, the qualitative definition, quantitative definition, then Coulomb's law in vector form. Then we discuss the properties of Coulomb's law, similarity and dissimilarity between Coulomb's force and gravitational force, and we solve some numerical. So with this I am concluding today's class, and next class we will start electric field. So if you have enjoyed this video, just like it and share among your friends. So we will meet in the next class. Okay, bye.